Alright, hello, my name is Tyler Klasky. This is Team 1, and we are pursuing the automatic can shotgunning device. So our mission statement includes key business goals, which if we want to have 5-star ratings on our product. We want to control the market for beverage can openers. Some of the primary markets that we're pursuing is college students from Virginia Tech. The customer needs and the use case oriented our product towards what the customer needed, what they wanted, and we specifically got this information from customer reviews, and then we sent the highest repeated needs back to figure out the importance of those needs. The specifications that we found from those customer needs that we got back are oriented into the QFD. This helps us with our specifications that's listed right up on the top here. The importance that our team had to follow to incorporate it into our product. So the concept generation and selection process, this is the functional diagram where you got 3 inputs. We got energy, material, and signal, and with our end product we're trying to get a puncture can. Each one of these inside of here, each one of these boxes are an individual sub-function that will control a process that we will incorporate into our final design. From here, we took all the concepts from our brainstorming 335 analysis and created a concept combination table, which you can see here. And we created 6 possible solutions right across the top, which we delved into later to figure out our final design. So our intellectual property helped the team figure out what other companies were doing, what other inventors were incorporated into the products. What we found here was most of the products that we looked up were nowhere close to where our product was, so there's no limitations on our design. And we found out some interesting things that we can incorporate into our own design, since most of these guys were, the patents were expired. After that, we created a failure mode after we selected our final design, and then we labeled the importance of each of those key components. So we got Arduino, we got the foam board casing, we got the glue, and each one of these can fail at a different has a different potential failure. And we weighted these to determine which ones are most important and how to address these to eliminate that failure once we move on to the mass production phase. The design and assembly process enabled the team to figure out the amount of time it would take for one worker to create one ACSD system or product. We used manual insertion here, and then also manual handling here and manual insertion here. Once we found those times from the tables, we found that it took 872 seconds to complete one item, and then we calculated with the $15 employee wage that one product would cost $3.64, which would be incorporated into the economic design or economic analysis. So here's the bill of materials. You can see where each material goes in our product right here. I know it's hard to see. Each material is listed, or each part is listed with a number specific to our design. Most of these parts in the top here are specifically were designed in CAD, and then some of these lower parts were either bought online or at the local hardware store. and incorporate it into our design. Now it's important to note that we incorporated a mass production factor, so if we would have bought all these, like we bought all these products at a hardware store, it would have amounted to $60.34, but incorporating a mass production factor, which would be equivalent to buying in bulk, each product would come out to $16.04, which then we could conduct another economic analysis with those numbers, and also the design for assembly cost for each product. So here is our final CAD drawing. It's kind of hard to see, but we got the linear actuator tool, or linear actuator here. We got the tool puncturing system here. We got the column support. These outside edges are the foam supports, and then we'll have a foam pocket where the can will fit into. Here is our design with the side taken off. We needed to incorporate a motor unit to control the linear actuator because the voltage from the battery was too much to control or plug into the Arduino. We also have another power source located in the front here to power the Arduino, and which eliminates plugging it into your computer. So this is our final design. This is Kyle's design. His prototype, or his final prototype, resembled the CAD drawing here the most, specifically with this tool design. It's important to note with the limited access tool, it took a very long time to create this, and with the tools that I had, I couldn't make those cuts, and it would have been dangerous. Some other important things to note here, we got the puncturing mechanism, which if we had enough tools, it would have been 3D printed. This is our reflection process. We would incorporate new ideas from the DFM, design manufacturing, to improve the process. Yeah, DFA to improve the process. We'd also look back into the design assembly to reduce some of the times to create the product, which will enable the product to be produced at a lower cost. And that is it. Thank you.